So for buildings that are single story or two stories and are just for, like, single households, they're not being used as shelters or for any other extended uses. To simplify the design and construction of this kinds of building, so there's this, like, come up with a home building manual. So most of the countries have this. This is associated with the 1990s National Building Code, and most are also still relevant. They've been reviewed recently by a number of firms or a number of experts, and they're saying that with just like, minimal tweaking, a lot of the guidance and examples that are mentioned here in the home building manual are still relevant. But then again, yeah, it only applies to houses up to 2 stories using conventional construction. And this manual is aimed at professionals and contractors looking for deemed to satisfy structural engineering solutions without the expense of extensively using an engineer. So here we can see that there's a long list of, like, caveat on the limitations and scope of the home building manual. It gives clear guidance on which circumstances they can only be used. So as mentioned earlier, can only be applied for, like, single story or 2-story house, and the plan should be a rectangle or a simple combination of rectangles. The height should not be more than 6 meters from the ground to the eaves, or not more than 8.5 meters from the lowest ground level to the top of the ridge of the roof. And I will not be going into the details of the other provisions of these limitations. I hope you can have a look or have a copy of this home building manual, so you can be more familiar with its proper use, considering the scope and limitations of the basis of their design recommendations. So here in this diagrams, may be difficult to look at this schematic drawings, but what if you'll be able to zoom out these figures, they are just indicative of, like, what would be the maximum height of the building from the ground, what would be the ideal angle or slope of the roof, where it can be applicable, what would be it's like the length of the buildings covered by this manual. It also talks about the roofing type that they are recommending, and also the supports of the roof that they are recommending. So the idea in this home building manual is that based on the it's like the sizes of houses that it can be applicable, and based also on the height of these houses, they are recommending the sizes of your columns, the sizes of your beams, the sizes of your truss, based also on varying wind speeds. So there's like a table that you can just look up. It's like you have the wind speed and the the size of your structure, and then you'll get the size of your building elements, be it like a column or a beam or a roof truss. So that home building manual, as I've mentioned, it's still very relevant and very helpful to builders, because it's like an engineer is not really required. All you have to do is follow the schematic diagrams that they have in there, and you'll be able to, it's like, get the proper sizing for your building materials. And recently they have also been updated to consider like the effects of stronger winds because of cyclones triggered by the changing climate. So we have here the guidelines for improving building safety and resilience of new single-story houses and schools in rural areas of Fiji. So this very recent publication supported by World Bank. So the same consultants that they've had also have looked at updating the home building manual in Samoa, and it is applied following, like, the revised National Building Code, the single-story residential housing, based on the Dominican experience following severe hurricanes there that heavily impact the general housing stock. So there are a lot of similarities of what's happening in the Caribbean and also in the Pacific. So there's certain level of like replicability of what they have done there as best practices that can also be applied here in the Pacific. So in this guidelines, they have made it more user-friendly. It gave, like, for example, the process of, like, guiding the process of obtaining a building permit. They have illustrated the risks to buildings, also the building design to address various risks, and they've also detailed construction methods, what good practices to follow, and also indicative costings of those interventions, and some other external agencies and building codes and references that they can use to ensure that what they are building are it's like based on solid principles. So this guidelines for improving building safety and resilience of new single-story houses and schools in rural areas of Fiji, it can be downloaded from the government website using this link. So from that guidelines, you can see the illustrations that they've had in there, and trying to make people understand more the implications of climate change. Like, for example, here the implications of strong wind and how it impacts buildings, for example, and what could be the design that they can do so they can withstand those strong wind. So in this, it's like figures. It demonstrates, for example, the risk of strong winds if your structure is not anchored well to the foundation. So or if the roof are also not tied or braced to the building. And there's also here possibilities of damage based on, like, the attached structures, like verandas that can be easily damaged by high winds. And then there's this implication of flooding uh, from heavy rains or very high tides. They also demonstrate not just the impact of climate change, but also how to address it and what are the poor and good practices that can be, like, the poor practices so they can be avoided, and the good practices so they can be replicated or emulated. So, for example, they have cases on, like, building houses on a slope, uh, what could be done and what should be done, and what to avoid, or in this illustration. They also have some suggestions, for example, on building shapes. Uh, they would prefer that the buildings would be symmetrical. Uh, the long and thin buildings are considered as undesirable because you don't have like an even it's like even surface of withstanding the the forces from wind or from earthquakes. So it has that tendency to twist, or it's like you need some breaks on the length of buildings. And some guidance also in choosing building sites, especially if you're near some slopes. You don't want to be positioning your building just or building your house just below a slope. There has to be like some considerable length of easement, so if landslide would happen, there will be less damage, or at least your house will be spared. There are also illustrations and examples of various types of foundation. This depending also on the the ground, the available ground, and the strength of the ground. So there are examples of, like, how to do strip footings, when is it applicable for step footings, for slab or raft foundations, when is it necessary to do pile footings or pad footings. There's also some guidance on the different types of roof that they are recommending, and and the slope of the roof. So I think what they have is preferably not higher than 25 degrees slope, but also not too flat, or not below 15 degrees, that it would be like really flat. So the guidelines also have discussion on construction methods for basic mixing of concrete, what type of reinforcement bars are needed, how to do jointing or splicing of rebars, or how to bend rebars, or what's the required edge distance for rebars. They have some guidance for footing and foundations, also on how to construct floors, if it's concrete or timber framed. They also have some guidance on how to build walls using concrete block and reinforcement, or if it's timber framed, the ideal basic framing sizes, the lintel beams and the bracings necessary, and cyclone strapping. So I no longer have further details on this construction methods, because I think I'm expecting that you'll be able to download the whole guidance document.